Times it by 2.
What other way? How can you
Divided by
get
1/2.
another? Add a plus a, right? Does everybody agree? I knew you'd get there eventually. Now, does that look familiar?
Yeah.
Do we know how to find the sum of the sine? Isn't it the sine of the first one, cosine of the second, plus sine of the second one? Whoops, I put B in, it should be an A, sorry. And cosine of the first one? So since these angles are exactly the same, I've got one of these plus one more of those, that gives me what? 2 of them. And didn't we just derive it?
Oh. Okay.
That's what deriving means, is you take something else and you make it become something else. Okay, what if I wanted the cosine of a double angle? Cosine of A plus A. So that would be, what's the formula for cosine of an angle plus another angle? Cosine of the first, cosine of the second, which is A, minus. So I end up with cosine squared minus sine squared, which, see, it matches it. Now, if you'll notice on your trig information sheet, I have that written 2 other ways. 8 identities are very helpful. What's another way of saying cosine squared from our 8 identities?
1 minus sine squared.
So here's the main double angle formula. But if I were to change it to 1 minus sine squared, I get 1 minus 2 sine squared A.
Yeah.
Do you see that on there?
Yeah.
So it could be written that way. Which when we start solving equations, you're going to want to refer to that double angle, the 3 different ways it can be written. What if I changed this? What's another way of saying sine squared? 1 minus cosine squared. So distributing by a negative, I get cosine squared minus 1 plus cosine squared. So what's cosine squared plus cosine squared?
2 cosine squared of A minus 1.
And is that the other formula that's on there?
Yeah.
Yeah. And then could I find the tangent? I could do sine divided by cosine, or I can use the formula, but mostly sine divided by cosine. So that you didn't have to write down. That was just showing you how to derive them. Now, what we're going to do is we're going to make use of the half angles and find exact trig answers again. Okay, we did that exact with sum and difference, and now we're going to do it with the other. Refer to your chart of the angles that we know. Does everybody see where I'm at? So let's say I want the cosine of, I want to make sure I'm not doing one of the ones you guys have to do. Yeah, I want cosine of 75 degrees. And on the first 14 and 15, you're supposed to use the half angle formula. So in order to use the half angle formula, so this is an example for 14 or 15. You're only going to do 2 half angle formulas because you got to do a lot of simplifying. What's 75 doubled?
150.
150. Now, look at the formula for cosine of a half angle. What, I have it set up now, 150 over 2, right? All I have to do is put it into the formula, which is plus or minus 1 plus the cosine of 150, all divided by 2. Does everybody see where I put things? The 150 goes in for A, basically, is all you had to do. Now, you can make this decision right now. What's the cosine of 75? Is it positive or is it negative? It's positive. So I know my answer is going to be positive. So I can forget that. Now, on your chart, what's the cosine of 150? And 150 is in the second quadrant, so what's the cosine in the second quadrant? Negative square root of 3 over 2 then, right? Now I'm going to rewrite this And I'm gonna use the butterfly at the same time. All I did was rewrite it. Does everybody follow what I did?
Where did we get the negative on the square root of 3/2?
Because in the second quadrant,
Mm-hmm.
is the cosine is negative, that's where it came from. Now, you guys ready to butterfly? What's the first wing? 2 minus what's the second wing? And it's being divided by 2, right? Which when you divide, don't you invert and multiply? So now we have the square root of 2 minus the square root of 3 all over
4,
the square root of 4, which is
2.
2. So I went ahead and got rid of the radical on the bottom. Is everybody okay with that? Because 2 times 2 is 4, and the square root of 4 is 2. Is everybody good there?
So the square root inside of square root.
The square root instead of a square root. And there would be your answer. Now, do you want to simplify that, or leave it there?
Leave it there.
Okay.
This looks nice.
Now, how can I check this?
By doing the cosine of 75 on the calculator?
Go to your calculators. Everybody's got their calculators handy. I want to make sure whether I simplified it or I kept it that way. So, both ways. Yep, you can leave it that way. So, what's cosine of 75? Somebody with their calculator. Decimal, what you get?
0.25.
0.25. Okay, now,
0.5.
did you get it on that too? The square root of, everybody agree with that? So you just check your answer. Let's do another example. Don't need to write this one down. I'm just gonna put it right in here. Let's say I want, the sine of 15 degrees. So what did I do first to find the sine of 15?
Doubled it,
I doubled 15, so that becomes
30,
30.
divide by 2.
So now it looks like the setup of the half angle formula. So put your information in. So it's plus or minus 1 minus the cosine of A, which A is 30, over 2. Now, make your decision now. Is it going to be a positive or negative?
Positive.
Because sine of 15 is in the first quadrant, it's positive. 1 minus, what's the cosine of 30?
Square root of 3 over 2.
So rewriting that, that's 1 over 1 minus the square root of 3 over 2. So can we do the butterfly? So 2 minus the square root of 3 over 2 times 1/2, all under the radical. So we get the square root of 2 minus the square root of 3 over square root of 4, which is 2. Now, double check that one. What's the sine of 15?
0.25.
And is that the same thing? And you guys can enter that okay without any difficulty? The square root of parentheses, 2 minus the square root of 3, close your parentheses twice and then divide by 2. Right? Did you get it, Mason?
Yeah, it's just on my calculator, it's harder to do.
Oh. Some of them it depends on the
Yeah.
calculator. Okay, we good there? Now, the next group, 21 through 25, you're going to be setting up a triangle and then you're going to find all three, okay? So, example for it, we can set up the triangle. They're going to have them in different quadrants, I believe. Let me make sure. Yep. There's a first quadrant, there's a first quadrant, second quadrant, and then there's third quadrant and fourth quadrant. So you're going to have all quadrants, basically. So 21 through 25, here's some examples. Let's say that I give you the sine of A is, you want nice first?
No,
Yeah.
horrible first though,
Yeah.
we know.
Yeah.
Horrible first.
Not so nice? Okay, doesn't matter to me. Let's say 3/8, and angle A is between 0 and 90 degrees. That means it's in the first quadrant, right? So you set up your triangle, and you only have to use the triangle. There's going to be a triangle for each problem. But once you get your triangle, then you're gonna answer 3 questions. Everybody see it? You're gonna use it 3 times. So what is the sine by definition? So Pythagorean's theorem, a squared plus b squared equals c squared. So square root of 55. Anybody else agree? And we're in the first quadrant. So in the first quadrant, we're going to have to work. We aren't going to have to worry, right? Now, what is the formula for the sine of a double angle?
2 sine of x is 2 sine of x.
So in our case, since sine's a, it's a. Okay? Now, you go to your triangle. What's the sine of a? 3/8. What's the cosine of a? Cosine is adjacent over, and then multiplying. What do I get? Well, I can reduce or cross cancel. 2 cancels 8 to 4, so I'm going to get 3 square roots of 55 over 32. I'll give you a chance to catch up there, Mason. So 2 was part of the
Right.
formula.
Mm-hmm.
Sine, you got from the triangle,
Right.
3/8. Cosine, you got from the triangle, square root of 55 over 8. They're in the first quadrant, so it means you don't have to mess with their signs. They're both positive. And then, all I did was multiply. In multiplication of fractions, it's straight across. Cross canceling when you can. 2 went to 8 4 times. So I'm left with 3 square roots of 55 over 4 times 8, which is 32. So everybody follow that one?
Yeah.
That's it?
No, that's all for that one.
Okay.
Now you find the cosine of a double angle. Now, which formula can you use for cosine of a double angle? Any of those 3 will work. It doesn't matter which. Why don't I use,
1 minus 2 sine.
okay, I'll use that one this time. Next time I'll use a different one, okay? So everybody follow what I'm saying? It doesn't matter which one you pick to use. So you guys want to use 1 minus
2 sine squared.
2 sine squared of a? That's the one you want to use. Okay, so we got 1 minus 2 times, what's the sine? 3/8. And we have to square it, right?
Yeah.
So we have 1 minus 2 times 9 over 64. So that's 1 minus 18/64. So what's 1 minus 18/64? 46? And I can reduce it, but I'm just gonna leave it alone for now. Well, no, I'm finished, so I wanna go ahead and reduce it. So that would be 23 over 32. Now, just for the sake, don't write this down. I could pick another one, right? Let's say I chose cosine squared minus sine squared. Cosine was what, radical 55 over 8? Sine was 3/8. So I end up with 55 over 64 minus 9 over 64. So what's 55 minus 9? 46. And I get the same thing. So it doesn't matter which one you pick, you should end up with the same thing. Okay, so I'm going to get rid of that now. Now we want to find what?
Tangent.
How can you find the tangent?
What do you got for sine?
Sine divided by cosine.
Miss Davis.
Yes, sir.
Oh, no, wait.
Now, could you use the formula?
Yeah.
Yes. But we can also just use the division. So what's the sine of a double angle? It's 3 square roots of 55 over 32. Right? Don't we already know what it is? And we're dividing it by the cosine, which if I divide, what do you end up doing? Invert and multiply. So the 32's are going to cancel. And I get 3 square roots of 55 over 23. Okay? Well, let's do another one. So I'm going to do it in this group over here.
wasn't that was that the easy one or the hard one?
That was the easy one.
Okay.
No, that was the hard one, sorry.
Oh, what?
Now let's do an easy one. It was one that had a radical in the problem.
Oh, okay.
Now I'm gonna do one that comes out nice. And we're gonna put it in a different quadrant. Oh, let's do cosine. Equals, 12/13. And A is between 90 and 180. So what's that tell me? Where is it located? And that means it should be negative, right?
Yeah, cause cosine.
So you set up your triangle. We're in the second quadrant. And what's cosine by definition? So this would be 12 squared plus b squared equals 13 squared.
Yeah.
So we're gonna get 5. You good there? Now, what are we supposed to find now that you got your triangle set up? What's the formula for sine of a double angle? So 2 times, what's the sine of A? And we're in the second quadrant, so it's positive. Cosine of A. And it's negative because it's in the second quadrant and cosine is negative. Then what do?
Multiply.
Multiply. So straight across multiplying, what are you guys gonna come up with?
Negative 130 over. Yeah. Maybe you can simplify that fraction.
Over 169? It doesn't simplify.
Was it
Right.
130?
No, it was 120.
120 over what?
120.
Oh,
120 over 169, 2 times 5 is 10, times 12 is 120, right? And then 13 times 13. You guys okay there?
Yeah.
Cosine of a double angle, which formula do you guys want to use?
Let's use 2 cosine A minus 1.
So 2 times, what's the cosine? Negative 12/13, and we will, I want 12 on top, not 13. And we want to square it, and then we want to subtract 1. So what do we get? 2 times 144 over 169 minus 1. So that's 288 over 169 minus 1. So essentially that's saying 288 minus 169, right? So what's 288 minus 169?
192.
Why would it be 280 minus
2 times 144 is 288, right?
minus 169?
1 would become, if you got a common denominator, 169 over 169.
Okay.
So that's what I'm saying, it's essentially saying it's 288 minus 169. Now, this is the answer for cosine. This was the answer for sine. What would I do to find the answer for tangent? Divide the sine by the cosine. So that would be a negative 120 over 169. When you divide,
Times 169 over 119.
you invert and multiply. And the answer is a negative 120 over 119. So you guys follow what you're doing in that section 21 through 25. 21 through 25? You guys want another one?
No.
No.
Another one?
No.
Good? Next group. Have we done this before?
Yep, verified.
Yes, we have. We're verifying again. And on verification, true verification is where you work with one side and one side only. I know there's a modified verify. I know the other class has been doing a little modified verify where they work with both. I work with one side only, and you make it look like the other side. Okay? Which it's always doable. Can't you work with either side?
No.
Yeah.
You can either make one side look like the left or the right look like the left, vice versa, but you only have to work with one side. So 28 through 30 we're going to be verifying. And I thought we'd just pick one from here, not of your problems. So you guys look at the ones 31 through 35 and look what you think might be interesting to look at. Although avoid number 34 and 35 because they're doing
31 through
triple
30.
angles.
Okay.
What was that? 31?
We haven't even talked about triple angles yet.
We're doing that tomorrow? Or are we gonna?
No.
get worksheet of this?
We're gonna do, we're gonna do something that's
454.
just a short little section, so it's not gonna have homework on the break.
28 through 30.
28 through 30.
32.
Can we do, yeah, 32. Sure.
Does everybody think 32 is a good one? 32. What does it say?
Seeking 2 angle equals cosine squared angle plus sine squared angle over cosine squared angle minus sine squared angle.
Make me right one.
Sine squared angle.
Did I get it read right?
Yes.
Yeah.
Okay.
Identity,
Yeah.
Now, first you gotta decide which side you work on.
right. Sort of.
Right?
Yeah.
Okay. Now, we could do either side. I can see this one working pretty quickly too.
Right. Just pick the random one.
So this one is the one you want. I think probably because you see something, right?
Yeah.
So that is
One.
1. This is also gonna show you that these aren't gonna take too much time.
That'd be
Hopefully you
cosine
recognize
2A.
this
That's cosine 2A.
of a double angle.
And like.
That'd be seeking a 2A.
Still amazing. Wow. That was like.
And that was past what you guys have to do. Everybody follow that? Mason, did you follow what we did?
Yeah, well,
You just have to know the formulas now, because the formulas are gonna come into the problem.
yeah, the double.
Double angle formulas. Okay, we good there?
Let's say this. Could these, if we would have known these before we started doing this, would there have been, like if we took a harder route, would these have helped us like simplify? Like if we didn't know that over formulas,
You mean the double angles and the?
yeah, for the double angle.
Yeah, it just makes it easier. Yeah. Okay. Let's turn off cameras, let's see. What are we doing today? Again, recap.
We are doing the half.
14 and 15 where you're doing half angle only, right?